will not get we will not jump immediately into our presentation today, but we'll start getting a few preliminary matters out of the way. We are so glad that you are here. We welcome you to the Salt Lake City R user group. We're really glad that you have found us. I imagine that you found us through our meetup page, but I will put this here. And this is where you can find out what events we're having, what's coming up for us. So this is we're meeting now for June. In July, we're not meeting because we're encouraging folks to, register and listen to talks from some of the great R conferences that are happening in July or at the end of June. I think USAR is at the end of June. And then our studio conf is going to be free to stream. So that will be in July. So we've got some really great community things going on. So we will come back together in August. So you can check our meetup page to see more about what we'll be doing come the fall. We would love to have you there. This is a friendly and professional space, and we use the R Consortium's Code of Conduct. So who am one of the organizers here, and Andrew will be moderating. We'll be moderating, chat, and we want to say that this is a space that, as if we were in person, we will treat each other with professionalism and be welcoming to each other. So we're really glad that you all are here. So this meeting is being live streamed on YouTube. So please do or do not have your camera on as you are comfortable. And we have on our YouTube channel, you can go there to see past talks, which is great if you miss one or you want to refresh yourself on one of those pieces of content, like some talks that may have been interesting to you that you missed. So we'll drop the link to our, so Andrew dropped the link of today's live stream, and then also we can maybe drop the link to our YouTube channel in general if you want to see past things. So I believe, I'll just say one more announcement, which is if you are interested in giving a talk in the fall, we would love to hear from members of our community for the fall. So if you have, a package that you learned to use or a project that you thought was interesting using R or data science in general, we would be so happy to hear from you as part of our community. I'm really excited about our talk today. So Jeremy Allen is going to be speaking for us. So Jeremy is a customer success manager at our studio. So we're coworkers. We're both coworkers at our studio. And Jeremy works with public sector customers, helps public sector customers use our studio products in production. And Jeremy's background is in the humanities as a researcher studying terrorism, and now he works for our studio. And I always appreciate Jeremy's perspective on ways to approach different problems and workflows. So I'm really happy that Jeremy is here talking to us today. So Jeremy, take it away.
Fantastic. Thanks, Julia. Can I just get a confirmation that you all can hear me okay?
Yes, I can hear you great. Thank you so much.
Fantastic. I'll do a little bit more bio on myself. While I do that, though, if you don't mind, everyone listening, type into the chat how many years of experience you have writing R code. Can just be a number, that's fine. And while you do that, I'll say a little bit more about myself. Yeah, so I've been at R Studio for, I think, 13 months. Yes, it was last May. Before that, had a long career researching terrorism, as Julia mentioned, mostly for Department of Defense. And so studied things like understanding Al-Qaeda as a social movement, Al-Qaeda's ideology, how they recruit people, Al-Qaeda media operations and propaganda. And, there's only so much Osama bin Laden content that I care to consume in my life, and I reached that maximum. And so fell in love with R and the R Studio products and jumped ship as soon as I could and left that career. And now, super happy to be here, helping people do something that I love, something that makes me happy and makes other people happy. And so, uh, I want to share some of that with you today. I want to scroll really quick through the chat. I see a 35. I see numbers as low as 1.5. Ooh, yeah, 6 months too. Fantastic. Yep, I see another 6 months. All right, 35. Has R even been around for 35 years? I don't think so. Someone might be pulling my leg.
No, Greg, really, yeah. Greg, I don't know if you want to unmute and just say that he's not pulling your leg. I don't know. You mean you may not be able to unmute and say anything right now, but no, Greg,
Oh,
yeah,
okay.
like yeah,
Early
Greg.
ports of this.
Yep,
Gotcha.
yep.
Okay, it's all come together now. I've been using R since 2016. So not too long. Self-taught, didn't learn at school. Background, all humanities, like Julia said. And actually, a lot of Julia's work is how I learned R. So her work on text analysis, the Tidy Text book, and the package were some of my first entrees into using R to study terrorism. But anyway, I also used to be a rock climber. I'm not anymore. Too much gray in here. Too much sitting at my desk these days. But there was something that I learned rock climbing that helps me with R, particularly with data transformations. And so I want to share that part with you today. Let's get our slides going. Awesome. So this is the question we're going to investigate today. Can we improve data transformation by using mental representation? Particularly mental representation of the data transformation process. And the mental model that I'm bringing from rock climbing is called route reading. And so in rock climbing, route reading is when the rock climber approaches a rock wall, they look up, they see all the features of the rock wall, and they start to mentally represent those features, how they might be able to hold on to them, stand on them, how they might be able to move their body up this wall, take advantage of those features, and then get themselves to the top safely, and then back down again. That's route reading. Let me know if you can hear this audio.
Hey friends, today we're going to talk about a process that's so crucial, it can enable you to send your climb before you even leave the ground. This is the skill and discipline of route reading. If you're struggling with progression, especially between V3 and V5, this process can really change the game for you. I referenced my climbing journal, and on March 20th, 2019, I started practicing route reading. At that point, I hadn't sent a single V4, but just 1 week later, on March 27th, I sent 2 on the same day. Even later on in your climbing career, route reading still makes a massive difference, and it speeds up the pace of progression significantly. I wanted to put this skill to the test by doing a climbing session at a gym that I hadn't visited recently. My rule was that I wouldn't start any of the climbs before reading the route and writing down all of the moves. That way, I was forced to record and refine my thought process before I even touched the climb.
So that's our introduction. And you can see here in the screen capture how at one point he was drawing his body movements and what they would look like. Let's get one more bit of intro here.
At its most basic level, route reading is going to be identifying all the handholds and all the footholds. But beyond that, you can identify the motion that your body is going to take, and that's going to be a crucial step too.
Absolutely. So that's what route reading is. I have 2 more clips. They're shorter than the ones we just looked at. But I want you to see this because this is one of the best rock climbers in the world. His name's Adam. And he's going to actually show us his route reading process at a rock climbing gym. And some of what he does is going to directly translate into what I want to share about how we can use route reading in data transformation. So let's see what Adam is going to do.
And then I think you really have to start motoring.
You can see him also practicing.
I think across the roof it's gonna get quite tough, and then in the upper head wall it's gonna get even harder.
Bude to i o nepříjemných krocích
Yeah, some
a
of it's
o
unpleasant.
takových záludnostech, které prostě ty lesce
See how much I can remember. This is the first hold. This one is kind of slopey. This one is kind of slopey.
So from memory,
There is a chip
He's
here. There is a
recreating the
chip
routes.
here. There is a volcano. You're going to clip here. And then there is a bad side pull from this part. And I think this is going to be rest. You're gonna have a heel hook here.
I
And
think is
then you
That's pretty
go.
amazing.
Whew, I'm not so sure.
All right. So if we were to watch this whole video, we would see Adam finish drawing the entire route, mostly correctly, and then thinking through how he's going to climb. Oh, awesome. So Britain's in the chat, and they're a climber too. So they're going to help answer our research question we started with. Can this help with
Trying
data
to find
transformation?
all the details. This is sometimes a section which I might do with somebody else in a
And
group,
then notice again
or
here,
sometimes I do it alone and discuss
actually using
later
their
in
body
the
to work through the
isolation zone.
moves before he begins. So this is the mental representation part, along with practice. And I actually did find some research that shows mental representation with practice gives the most improvement over just one or the other. And here's just a sample of that. Cornelia Frank from 2014. And then the main point there bolded at the end is that the combination of mental and physical practice has been found to be effective, or even superior to just physical practice alone. And I am trying to find research on transferring this to programming. Here's what I found so far. Really good stuff. Okay, actually, right before this call, I did one other search and I found something that's getting close, but it's not quite there. But this is a paper on mental imagery and software visualization. So I still have more to do. So be thinking, if you know about research that is studying using mental representations for programming skill building, then once we end and we have a conversation, bring that up because I want to know. All right, let's head over to our studio and let's start looking at some code. So I was given some real world data from a colleague probably a year ago, and it involved some very messy data. And looking at the data, initially I knew right away, okay, something's not quite right about this data, at least not right in the sense of it being in the shape I need it to be in so that I can do the analysis that I need to do. So I've made some fake data here that we're going to take a look at, but this fake data represents the actual shape and format of the data that I was given. And then I'm going to walk you through some of my mental representation practice and how I ended up at the right place with my data, which was in a tidy format. Every row was an observation, every column was a feature of each observation. So let's get everything loaded up. And by the way, I'm working on our Workbench product in the browser on our public server at our studio. All right, so imagine here we're walking up to the wall. So we're the rock climber. This is our wall. It's our data set. And we can just take a look and see what features are afforded here. So we have unit ID, and we have 3 of those. All right, so I'm starting to get a little sense of what the level of analysis is here. We have some dates. Here's the big, hairy, free text field. So I have a description of these. And then I have these other columns. So I have some weight and length columns for some different subunits. Okay, that's interesting. But let's take a look at it. And I'm actually going to open it up in the view panel so we can see it better. All right, so my fake data is about peppers because I like spicy food. And so let's look at this rock wall. We see we have 3 unique things, and those might be what we need to study. But if we look at the description, we're going to find out it's not actually what we want to study, because I'm seeing within each unit, within each row, I have multiple subunits. So I see 2 subunits here in this description. It looks like some kind of review or rating. So, you know, pepper 1 was great, and here pepper 2 is cool. I'm going to make this bigger just in case you can't read it. So this actually is starting to look like we have batches of peppers. We have 3 batches of peppers. So each row is a batch. And then within the batch, we have some ratings here. In batch 2, pepper 1 is awesome. Pepper 2 is amazing. And the third one's a little different. Pepper 1 is bad. 2 is gross. And 3 is, you can't really see it here. We'll see it in a second. But 3 is rotten. And we'll take a look at that down here. Yeah, so now we can see pepper 3 is rotten. So starting to think about some ways we can climb this wall. I'm starting to see some features of it, some things that I don't like, some things that might hinder my analysis. Let's take a look at the names as well. All right, so I have this unit ID, and here I'm noticing some difference in the names. So for the weight and the length of each pepper, I've got this subunit ID attached, but that's not how the description column is named. And so here, like Adam, I'm going to sit down, I'm writing on paper, and I'm thinking about, what am I noticing on this wall? What am I noticing in this data? It's kind of just a free association. What's coming to mind? So as we already mentioned, the level of analysis here is these batches. But in the real world example I was given, I knew I didn't need to study batches. I knew I needed to break this down at the individual pepper level. And all right, I've already mentioned I have this ID column and I have subunits mentioned in the description column. So I'm already thinking I've got to make some kind of move that's going to break this description column apart. And I need it to everything to line up at the subunit level of analysis. So 1 subunit per row. And I saw that the description column is not named like the other feature columns. The other feature columns were named with a subunit ID and a value with an underscore between. Descriptions not like that. And then this weird third row, it actually has 3 subunits in it. So it's talking about 3 peppers, not 2, like the other ones. So we're probably going to end up with something weird when we transform this, because I have a different number of subunits in each batch. And then one thing I wrote down is this, this memory that came back to me of there's a certain an argument within the pivot longer function that might come into play here. And I remember seeing it in this, the help file in the section multiple observations per row. In fact, let's just go over there and take a look. And we'll go down to the examples. So this memory came to me, right here, multiple observations per row. I know that's that is what's happening in our data here, because I have a batch per row, 2, sometimes 3 observations per row. Some of that's delineated in these column names for weight and length, but not description. All right, so I'm beginning to think this is going to be one of the moves I have to make. This pivot longer. And then because I'm noticing the weird naming conventions and how at least they're not consistent, I'm thinking somehow I'm going to end up using this names pattern argument, particularly with these that are consistent, having an ID underscore and then a value after. So I think that's going to come into play. So let's go back to the slides. We'll keep going this way. And so you can see when I had this original problem and I sat down and made these notes, just letting things come back to me, making, more observations about the data in front of me, just like Adam was sitting down, and from his memory of looking at the wall, he's trying to recreate it, and he's noting things like a rest point here and where he's going to have to clip his rope. So just right now, doing the mental moves, doing the mental representation. And that's what I was doing when I was originally given this problem, which matches up sort of like the intro we saw, where you're labeling your route, what kind of holds are being afforded to you, and how you might need to move your body. So let's take a quick detour, because I want to inspect a little bit more what these artifacts are. I'm calling them artifacts, call them whatever, memories, things you've done in the past, affordances, whatever. So I just wanted to pinpoint some of those and be really specific. So sections of help files. I don't know why. Those come back to me a lot. I usually focus on the usage section and the examples section. And part of my learning process is memories of seeing them. And so like I remember where on the page or in the help file I saw a certain chunk or a paragraph. And so it kind of comes back to me that way. And one thing you can do, quick shortcut I'll show you, is the F1 key. So let's click on the names function here, and then I'll just do F1, and it opens up the help menu to names. So that's one way you can be working in your code, and then real quickly just click into a function name and hit F1 and open that up. So another artifact that comes back to me is my past code. And again, it's sort of visual for me. I'm not sure if it's that way for you, but I will remember writing pieces of past code. There's some things that can help resurface some of that. Go back. So FZF is a command line utility. If you want to install it and you're comfortable using your terminal, you can use a tool like FZF. It's a fuzzy finder, a fuzzy search for files on your system. And you can use grep. You can set up rip grep if you want to use a faster version of grep in the background. But basically, what this fuzzy finder utility does is it presents you with a list of documents that match whatever it is you're searching. And so you can build your grep search first. And in my case, I'm just wanting to search R Markdown and .r files. And you pipe that into FZF. And so I've used this on my own system. I don't really have it set up here. Let me show you. I have a little bit of it set up, but I don't have it all configured. I'm on my work computer right now, but on my personal computer, I have this configured to do a little bit more. So in this case, I was testing this before the call. I'm just going to search for the pattern geom in my current directory. And I'm just going to look for that pattern geom in R Markdown and R files. That list is going to get piped into FZF, and we'll see what that looks like. All right, so it searched, it found them, and I can just use my keys to navigate through these. So you can see it's giving me a file path to files that include the pattern geom, and then it's giving me the line in that file. So this is a way that I can go back through my code and be like, when did I do that? Like geom violin or something I don't use very often. And I want to see how I wrote it in the past. So something like this is a way that you can quickly go through what you've written and resurface some of these artifacts in a way that may help you surface some memories that might be helpful for whatever you're working on currently. So let's jump back to the browser version. And the third artifact I find super helpful, other people's code. And I do this all the time. Because I told you I was self-taught, no computer science background. When I first started this, someone said terminal. What's a terminal? Why do you open it? What does it do? I had no idea. All right, so other people's code was really important for me. And a quick shortcut I can show you in our studio is F2. And I think it works pretty well on the pivot longer function here. So let me just skip down to that really quick. Yeah, so if you're in there and then you just want to F2 on that, you can see the source code for the function. And in this case, the actual guts of the function is just use method, not too helpful. So come up here and on this drop down, you can see the methods. So let's look at the source code for this function applied to a data frame. Now we can actually see the source code of the function. So that's this section down here. And so if I was in this particular mode wanting to know what pivot longer does, yeah, I could come in here and kind of investigate. So there's this other larger function building a longer spec, and then a pivot longer spec. I can see what it's doing there. These are functions. And so you can also F2 on those. And now we're a level deeper. We're in the pivot longer spec function. And I can see what someone's doing here. Some of this actually doesn't make any sense to me. But when I'm really in a good learning mode, this is super helpful. And if you can't find it in the browser like this, just go to GitHub, search, find the package, dig through the R files. I do that a lot as well and find good stuff that way. So F2 on a function name, and then just keep going until you feel like you understand what that function's doing. All right, so those are some of the artifacts. Yeah, FCF, I'm looking in the chat. FCF, yeah, it does. It can be incredible if you set it up with the right config file. It can also do some weird things. I had not set it up on my work computer yet, and I was trying to do it this morning and broke something. So do it at your own risk. All right. So after I had looked at this data, just like Adam, after he made his drawing of the rock climbing wall, I start to move into this phase of sequencing the transformations. And so in my case, I knew about the separate function because I knew I needed to use it to separate out these descriptions, because there's descriptions of more than one subunit in here. So I know I need to use separate. And I think if I sequence that into pivot longer, it's going to give me what I want, which is this tidy data set in the end. And in particular, I'm thinking about this into argument because I know into lets me provide names of new columns. And I start to understand I need the name of the description column to be the same format as these other feature columns with an ID, underscore, and a value. Because when I pivot longer, I want to use the names pattern argument. And so I want all of these columns to have the same type of name so that pivot longer will work on all of them. So now I've identified some of the moves I'm going to need to make, and I have them sequenced. And I'm already starting to see in my mind what the next version of the table is going to look like. So if you look across the top now, you can see SU1 underscore description, subunit 2 description, subunit 3 description. If I can achieve that, then all of these feature columns will have the same type of column name. So that's what we're after. That's what we want to achieve. And so let's run through some of these steps in our code and actually see it happen. All right, so we need to run our separate function and take a look. And we just ran separate on the description column, and we're going to use this into argument to control the new names for the new columns. And you can see, because I'm in control here, I can use this ID underscore value type of name so that when I separate the description column, it's going to match the same style of column names as all of those others. And we can take a look and we can see that is the case. So that's looking good. So now when I pivot longer and I want to do something with these column names, they all look the same. So that's going to make it easier for me to pivot longer. And when I do that, basically what I want to do is I want to split off the subunit from its value. And I'm going to have to do that using that pattern match function. And you can see that here. So the names to, when I pivot, is going to be 1, the subunit. So if we go back and look, I'm going to peel off this SU1 underscore. That'll be the name of a column. And then the value, which will be either description or weight or length, will be the other one. And then just using a regular expression, and I say just using I know every time I hear a boss or a really smart person, smarter than me, use the word just, I know they're actually skipping some amount of knowledge or work. So I just caught myself using the word just. So yeah, regular expressions can be a pain, and takes a lot of help. And that's what I'm doing here. And I've set up a regular expression that's going to capture the SU followed by a digit, an underscore, and then followed by repeated word characters. And if that works, we will have pivoted longer. Let's take a look. And it looks like it worked. Let's go back here. And so now you can see we were able to peel off that unit ID, subunit ID, into a column called subunit, and I have all those subunit IDs listed. So now each subunit, or in this case, each pepper, not batch of peppers, each individual pepper is a row, and that's what I wanted. And then the batch ID just gets repeated. And so the unit ID, each one of those is repeated 3 times here. But if you remember the first 2 batches, they didn't have 3 peppers, they only had 2. So we end up with a few rows here that have NAs for all of those features. And so we have to clean that up. But that's not a big deal to remove. And then when we do, we can see how it started and how it's going. And it's going great. We now have a pretty clean data set here. Let's go back and run that last cleanup step. And there's multiple ways you can do this. Hadley shared one with me on Twitter a while back, and I've already forgot it. But it wasn't just filtering for not as an A. I think it was an argument to another function. Maybe somebody on the call knows what that is. But there was some other way Hadley did this, and I think it even removed this last step. All right. We're getting close. So route reading in our stats. The first one's really big. Look at the data with your eyes. Actually go in, read those text fields. If you have billions of rows, you're probably not gonna be able to do this for everything, but you can do enough samples to actually go and look at it with your eyeballs and look at the column names with your eyeballs and start thinking about how certain moves will unlock follow-on moves. And then if you link enough of these together, you get the data transformation that you're looking for. Mentally represent what that end state is going to be. Oh, thanks, Julia. I see in the chat the values drop in a argument. Awesome. So maybe I'll go back and I'll rewrite that. Cool. And another part of route reading, consider the possible transformations. What have you done in the past? What have you seen someone else do that you think might work on your current code? It doesn't have to be perfect. You saw Adam drawing all the handholds on the wall. It wasn't perfect. He missed a few. That's okay. And in my case, when I was doing this on the real world data, and I was at this step, let's see, I was at this separate pivot longer step here. I didn't understand the names to and names pattern arguments. So right here between separate and pivot longer, this was a really iterative step. And I stayed here probably for a few hours and kept going back to the help file for pivot longer and looking at the examples. And, I think I found someone else online that may have used an example that was similar to mine, and it started to click, right? So this part is not always smooth, very iterative in my case, and took a few hours for me to sort out. Totally fine. In my case, it was fine because I had time. So another part of route reading, letting these memories, letting these artifacts resurface, and then think about sequencing your moves. If I do something here, how is that going to unlock or link to the next thing that I might do? And then just like in rock climbing, when you're done, review, see how it worked. In my case, right after I had finished this originally, I made a gist for GitHub and shared it to see if anyone else had any thoughts about it. And that was when someone had shared that values drop in A argument with me previously. So review is important. And if you're okay with sharing it with the public, that's a good way to get a review from people who have different life experiences than you and different memories. And maybe they are aware of some ways you can do this that you weren't thinking about. And now, questions for you. We do have time for Q&A, so you're welcome to ask me some questions. But what I would like is to also have you answer some of these questions, because I know a lot of you have really tremendous amounts of experience, even more than me. Someone in here with 35 years of experience, perhaps. What are some of your favorite data transformations? And do you have any particular sequence of data transformations that fit together well and then unlock new opportunities for you in your data transformation? And then do you mentally represent this? Do you write down these transformations before you make them, or you just go right into the console and just start typing away and seeing what happens? A lot of times I do that. Only occasionally will I write down some of the things. And it's not always on paper. Sometimes it's in a file, like you saw me do here at the top. I just made a bulleted list of my observations. And here I'm considering that, writing it down before I actually do the thing. So, question for you, or questions for you. Happy to take any discussion at this time, unless, Julia, you have anything else we need to do before that, but I'm happy to go into the discussion now.
Yeah, that's perfect. So if you want to ask a question or talk about maybe transformations you have found helpful or that you have used in the past, you can type into the chat, or you can use the raise hand feature and we can unmute you. We definitely would love to, like, these are the kind of things that when you see someone else do it, you're like, oh, right. That's so useful. And you may have, I know I may have either tried to do something in a more awkward way or in a way that doesn't give me as much control. So it's really so helpful to hear about people do things like this. I might kick us off as folks are thinking about that example. I might kick this off by asking you a question about you said that you showed how to find the inside of a function, right? Like when you're in RStudio, let's actually look at the function. Let's go down and see what the method is. And then you said sometimes you look at GitHub, and I'm wondering when you find yourself doing one versus the other, actually you're in RStudio working, you're going down to the function versus searching, searching on GitHub to find people's code examples.
Yeah, it's a good question. I don't know if I've really identified yet what makes me do one or the other, except for this one thing. So really, really early on, I didn't know that I could just hit F2 in the IDE and that it would bring up the source code for the function. And so early on, I just always went to GitHub and searched for the package. And then I would look in the R folder, excuse me, and I would kind of navigate around that way. And I found that very enlightening. And I think I was preparing a talk on tips and tricks in RStudio. And so then I started scouring the web for all the tips and tricks and discovered F2, which isn't, I don't know, it's not really a trick. If you know about it, it's very simple. Just hit F2. But I can say sometimes it's easier to read in people's R scripts on GitHub. They space things out more, and sometimes it's just an easier reading experience. On the other hand, one thing I like about doing it in the IDE is when I see a nested function, it's easy to just F2 on that internal function and then reveal its source code. Whereas in GitHub, I have to go out of the particular function file that I'm in, go look through the list of other function files in the project, and hopefully the file name is representative of the particular function that I'm looking for. And sometimes maybe not, just depending on who wrote the package, it may not all be that neat and easy. So if you're trying to dig and unnest a whole lot, it can be easier in the IDE. But in terms of a reading experience, I think I like reading it on GitHub better.
Yeah. Yeah, I think I find myself using like it in RStudio if I maybe like have data that I want to kind of like run with bits of the code. Like if I'm like then going into, I'm like, okay, what happens if I run that or I run that? Maybe so if I think I do it more if I'm actively doing something with some data, I'll be more likely to try to get access to the function easily, like within my IDE. And maybe if I'm more in like exploratory phase, I might use GitHub. For anyone who doesn't
Makes sense to
know,
me.
for anyone who doesn't know, I'm going to put a link here for there's a new search functionality that you have to get onto a list for with GitHub. Like you have to say, please give me the new search. But it is pretty cool. It's like it is much better than their old search, and it also lets you be very specific in like what kinds of repos you look at and all that kind of thing. So if you're someone who does that a fair amount, you might want to sign up. We have a
Cool.
couple of people who submitted or typed in ideas for things that they find themselves doing. One of them is about deduplicating, which is very interesting. Like using grouping by what you want to deduplicate by, and then using slice or summarizing or something like that. I think I'm trying to think if I do anything in a different way if I need to deduplicate. Sometimes I use, well, I don't know if you have a initial thought, Jeremy. One thing I use is distinct sometimes, but it's a little bit, you don't have quite as much control. Like it'll just, like if you need to group by and summarize to be very specific about, say, which of the other columns you want or how you want to summarize the other columns that you're not grouping by. But I do use distinct for that, which is also from dplyr.
Yeah, I have a couple of thoughts. I've had a few past experiences with deduping or deduplicating, but the ones that come to mind are where I had to identify which rows or which cases were duplicates. And I remember for a while, there was in the duplicate or duplicated function, I think it was past tense, maybe it's duplicated, there was an argument about the direction. So the direction that it's going to scan your data set and find what is duplicated. And I was just kind of off to the races and running, seemed fine. But later I realized I actually needed to run this function twice. But I can't remember what it was at the time that made me realize I needed to do this. But then I also needed to flip that argument and have it run from the bottom up instead of from the top down. And then for whatever reason, doing that let me see which rows really were, or which cases really were duplicated. And it kind of gave me the best coverage and the most confidence that I actually found what was duplicated. And then in another case, I had a lot of addresses that were mistyped just by one or two characters. And so I discovered the string dist package, string dist. And they have a few different algorithms you can access in that package. And so it gave me a better idea of what addresses were not showing up as duplicated, because they might have had one character or space or something that was off, but were in fact actually the same addresses.
Yeah, nice. Yeah, I've used that one a fair amount as well. It's really great. Greg, so Greg is our person who's like 35 years using R and S before. Greg said one of the things he does a lot is like the pattern of like split, apply, and then recombine afterwards, and using like plier or like now per for that, where it has all those map functions where you can map over elements of a list. And for sure, I use that a ton.
What are some examples of using that?
Yeah. So one thing that I have used it for, both in like my work as when I was a data scientist, and when I had like lots of data I was actually dealing with on a daily basis. Like one example I would do with there is, for example, training little simple models on like you have a lot of data, and then let's divide them up into some group, like split them the way Greg says, and then train like little models for lots of different, say, if you have 20 subgroups that you're looking at or something like that, and then you can train these little models, and then use the output to understand which groups do we see evidence that something is changing for, or which groups do we see are changing the most, or either up or down or something like that. So that's a real common one that comes to mind for me.
Yeah.
Yeah.
Anybody else have interesting examples of data transformations?
Awesome. Well, thank you. Yeah, okay, go ahead. Sorry, go ahead, Jeremy.
Well, really, this was it. So the gist that I mentioned, it is at this link. I'll try to share the slides, but if I can't, you should be able to copy that down really quick, or we might be able to get that into the chat. And then the actual repo, if you want all the code that we went through in our Markdown doc, that's at my site on GitHub, and the repo is Visualize.
Awesome. Well, thank you so much, Jeremy, for
Thank you.
I appreciate so much like the idea of like being able to think about how we approach some of these problems, so that we can be better at them, be less frustrated, be able to share with other people around about them better. So that's I really appreciate having had the opportunity to think about that for a bit today. Thank you so much.
Yeah, you're welcome. Thanks for letting me talk.
Yeah.
Nice to meet everyone.
Great. So this was our June meeting. Like I said, we're not having a meeting in July. We encourage you to keep an eye out for UseR, which you can register for to watch remotely. It's all remote. Our Studio Conf is has an in-person component, but we'll be streaming for free for folks who are not able to come in person. So look for both of those and sign up and like learn some stuff, and come to some learn some things from our community over the next month to 8 weeks. And then you can look for us for another meeting starting up in the fall, probably in August, but certainly by September. So thank you all, and you have a great couple of summer months.